Lesson 1, Radical Functions Part 1. In this unit, we'll graph and analyze radical functions and determine solutions to equations involving a single radical. We also graph and analyze rational functions and determine solutions to rational equations. So this is kind of the stuff you probably didn't like for Math 20. Okay? The rational equations, if you forgot, those are the fractional ones. Okay? You got stuff on top and bottom where you find the non-permissibles, all that stuff. Okay? So keep all that stuff in mind. So, radical function. A radical function is a function which contains a radical. The simplest radical function is y equals root x. We'll talk about how this changes. So, what changes the inside? What changes the outside? What does the k do? Turn them up and down. So, we're just going to talk about the movements of a radical function now. Okay? Any questions thus far? All right? Okay, let's go ahead and sketch this one. So, sketch the graph of y equals root x. We will see right away this right here, not defined. Not defined. We know that. We can't square root -4 or -1. Okay? 0, we get 0. Square root 1, we get 1, 2, 3, and 4. So the graph starts at the origin, and equal to 0 is okay. Okay, 1 we're at 1. 4 we're at 2. 9 we're at 3, 16 we're at 4. Okay, and it just keeps coming like so. Okay. Okay. So explain why the domain of the function is not a set of real numbers. Okay, so explain the domain. So x can't be negative since they're square roots, so we have to go ahead and cut off the negative. So what that's saying is why can't we just say it's all reals? Why can't we say XER? Because we can't have anything over here. Okay? So negative numbers are not in the domain for x. Okay? So I'm just going to keep the page here, but below you guys it says state the domain. So domain is what? Yep, x is greater than or equal to 0. What's the range? Same thing, right? We're growing forever positive with x, and we're growing forever positive with y. Okay, so you see this graph keeps going up, and it keeps going right. Nothing left, nothing down. It's kind of your giveaway if you're not following. Range, y greater than or equal to 0. Okay, good. All right, so this one they're just going to give you the transformations. What happens when you transform this graph? So we're applying our transformation knowledge. That's why we did transformations in Unit 2. So here's all the transformations we can look at. We're used to all these. So transformation, a vertical transformation of these is going to be when you add to the function. So f of x plus k, so it's got the constant on the end, right? That's the up and down movement. Okay, horizontal is on the inside. Okay, the x minus h on the inside, and it's opposite. Reflection on the x-axis, so that's vertical reflection. That means you're flipping y, so the function is flipped, so you have a negative in front. Reflection on the y-axis, your x has a negative on it, so f of negative x. Say that again. Good question. So yes, it can, but this is where it gets kind of flip-flip. So let's just say I had negative x, let's just say negative x plus 2. So what that does is that whatever I put in here, the output of what's in here can't be negative. So for example, if I put 0 in here, is that okay? Because 0 plus 2, right? If I put a negative 2 in here, what's a negative negative? So see, what happens, it flips your domain. That's why it reflects over the y-axis. Do you see what happens? So you want negatives now. So when you have a negative x, we want negatives because a negative negative makes it positive. Right. Well, it could be up to positive 2 on this one. Because if you have positive 2, you're at 0. But 3, no. 4, no. Yep. So do you guys hear that? It's a really good question to cash out there. So you see the negative x, and it immediately makes you go, oh, no, we can't have negatives. We actually want a negative. Because when I put a negative in here, it flips that back. Okay, so it flips your domain, which makes sense. It flips things over the y-axis, right? So we were good. Think about it. We were good over here. Now we're good over here. What did it flip over? The y-axis. Got a little stick figure there. It's pretty cool. Okay, makes sense? Okay, so that's the y-axis. Y equals x, again, that's the inverse. So the inverse, flip x and y and solve. Interesting enough, does anybody know what the inverse of a root x graph is? Yeah, it's x squared. And that's the weird thing, because x squared has two sides. So what happens is remember we talked about this, we can't get a bigger domain, right? Remember we talked about that? We can't get a bigger domain. So when I do the inverse of this and I switch these, it's going to be x equals root y. So it's x squared equals y. This one's domain still has to be x greater than or equal to 0. So we only get half of the parabola. We don't get the whole thing. That's important, remember? We don't improve our domain when we do our inverse. So if you're not following, our root graph looks like this, and then our inverse looks like this, and you can see they're reflected on the y equals x. It's kind of cool, okay, how it lines up like that. Okay, vertical stretch about the x-axis is the 1 over a that's on the, again, that's the front, the a in front, that's your vertical stretch. We're used to that. The horizontal stretch comes with the b. This 1 over a thing is kind of weird because it's just going to be, don't worry about the 1 over a on that because it's what's in front of the radical, so it's just a. All right. And this one for horizontal stretch, x to bx. So this one is bx in the front. So it looks like this one's not going to be 1 over, but we'll investigate that in a second. Okay, so it looks like the what's inside, it's going to stay that. Okay, let's look at these here. Again, to build them, we go stretches first, reflections, then translations last, order of operations. All right, here we go. Let's look at this one. Okay, so describe the series of transformations required to transform the graphs and write those in words. Make a rough sketch of the graph on the grid provided. State the domain and range of it, and verify using your graphing calculator. Okay, so let's go ahead and we'll do this one together. I'll let you guys verify on your own, but we'll go ahead and go +4 first. I just want to have it written the way I like it. So it's y equals x plus 2 plus 4. So when I'm writing this one out, do I have any stretches? There's nothing on x. There's nothing in front of the radical, so there's no stretches. This one's simply translations. Does everybody see that? So this is going to be a left 2, up 4. Writing it in words there. Left 2, up 4. We'll make a rough graph. Okay, so I'm going left 2, 1, 2, 3, 4. So right there is where I'm going to be. You can kind of write a little dotted line here if you want. There's no stretches, so it should be exactly the same shape. Just so you know, if I'm going over 2, right, to get to the y-axis, then where should this go through the y-axis? So we know that, what's that? Actually, sorry, it shouldn't be 2. 2 is going to be hard. It'd be root 2, remember? All right, so this is what I'm saying. If you do a 0 here, right, it's going to be root 2 plus 4. And so my point is root 2 plus 4, root 2 is not a whole number, so it's going to go through as a decimal spot for your y-intercept. Because root 2 is like 1 point, what is root 2, guys? Like 1 point, somebody do that for me real quick? Like 1.3, 1.4? 1.4? Yeah. So that means, like what I'm saying is that here's 1. So this is like our new 0 line, right? Because we moved up 4. So what's going to go through like this? That's what that's doing in terms of this movement. Okay. Any questions? Okay. State the domain. So what's the domain of this now? So domain does change. Greater than -2 and equal to, right? We can be -2. Okay, good. And what's the range? Greater than or equal to 4. Nope, positive. You can see it in the picture, right? 4 is the lowest point, and it's growing from there. Okay, if you want to verify in the graph calculator, you can. Go for it. I'll pause the video, let you try that. Okay, make sure you're putting that in correctly. All right, you guys are finished that up. I'm going to go to the next page here. All right, so we're doing the same thing for these 3. So I'm going to go ahead and do these 2. I'm going to let you guys take a shot at D on your own with your table partner. Okay, so first one is, like, again, it's nice to have y by itself. I think just for b and c, real quick, I'm going to get y by itself. So this one's going to be y equals 1/2 root negative x. Do we see that? Divide the 2 over. Okay. And then c is going to be y equals negative root x minus 5. Okay, so we're writing words, what's happening? Okay, so what's happening? Give me one of the things on B. Lauren, what's one thing that's happening on B? Not horizontal. It's in front. Vertical stretch, and it's of 1/2. Because vertical stretch is what you see.
Oh, yeah.
Yep. So vertical stretch is 1/2. Okay. What's the other thing we're going to have? Right. Flip over the y. The x is negative is what Cash is asking us about. That means we want negative values. So it's going to flip or reflect over y-axis. Okay. So let's go ahead and do this. So let's switch here. Let's go back to black. So it's going to be flipped over, and it's going to be 1/2. So what's going to happen is, it's kind of easy to do this, because when you plug in a -1, what's root 1? 1. So then times that by half, it's going to be 1/2. So you can see that curve's going to shrink down a bit. It's not expanding, it's kind of shrinking down. So normally at 1, they're at 1 here, right? Well, at 1 here, I'm at 1/2. So it's going to be a bit lower. Okay. The next one, so you like to just plug in, when you're doing radicals, guys, it's nice to put in perfect squares, right? Okay, so like the next one, I'll look at -4. Well, -4 square root of 4 is 2. Half of 2 is at 1. So I go here all the way to 4. Now I'm at 1. And so now you get enough to kind of make your tighter graph there. Okay, so the domain for this one, what's the domain? X is less than or equal to 0. Good. What's the range? Right, the range didn't change, correct? Okay, good. All right, and we'll look at C, then like I said, I'll pause and let you guys try D. So looking at C, we have a, what do we have in words? Flip over X, good. Down 5, good. Okay, cool. So that means we're going to flip over X, and we're going to go down 5. So we're going to go 1, 2, 3, 4, 5, and that means it's going this way. Like that. And then when you sketch, you can always check. You can be like, okay, well, what's happening at 1? Well, when I do 1, square root of 1 is 1, -1 minus 5, so -6. So at 1 here, I'm at -6 right there. Okay, and you can see how it pushes it below. Okay, so this one, a little trickier. What's the domain for this one? Domain still x greater than or equal to 0, right? So you're noticing when we flipped over the x-axis, the domain didn't change. We flipped over the y-axis, the range didn't change. Okay, but what about this one for range, though? Y is less than or equal to -5. Good. Okay. Any other questions there? Okay, give you a couple seconds here. Go ahead and try D. I'm going to take attendance, and then we'll be right back. All right. So this one, what in words do we have? Okay. Okay, hold on. Okay, it's a vertical stretch of 3, yeah. You said horizontal stretch of 1/2, okay. So, yeah, so there's a couple things you can do that, you're right, okay. A couple things you do. I just wanted to show you that since you said 1/2, watch what happens when you take a half out. So if I take if I time this by a half, no, that's not what I want to do. So horizontal stretch is 1/2 because that's 2, right? And so we do want to do the 1 over still, so that's still prevalent. I told you I'd come up again. You said the shift is what makes this whole thing 0. Now, remember, what I was trying to say was, if this is factorable or you can pull a common factor out, then do that. That's going to be your flip of your horizontal stretch, just like before. So what I'm saying is, let's just make one up. If it was 4x minus 2, you should do what? Pull a 2 out, right? And then you have the 1/2, right? So my point is that your horizontal translation, what makes that 0 is plus 1, 2. So it's to the right 1/2. Because that's what makes the inside 0. Okay, remember, your translation is always what makes it 0. That's just up and down. Yeah. Okay. So, yep. Yeah. So you pull the 2 out. Yeah, so you can pull the 2 out. It's 1/2. So it does still flip like we had before, which makes sense. It should flip, right, on stuff on the inside. So remember, when we see 2, it's 1/2. When we see 3, it's 1/3. So that's what 3 would be. Yeah, if it was a 3 instead of a 2 there. Yeah. Yeah. I'll double, triple check on that one, but I'm pretty sure it does still flip like last time. Because remember how that was with our transformations? I hope it's that because I don't want it to be different. Okay? Okay, so anyway, we're good. So vertical stretch 3, horizontal stretch 1/2. We're going right 1/2. So that means we're going to be right there. Okay. So you can plug some things in to get some values. So like a good one to plug in could be like 1. So what's happening when I put a 1 in? Well, 2 times 1 is 2. Minus 1 is 1. Square root of 1. Oh, yeah. Square root of 1. Oh, I see what you're talking about with that, Cash. Is 1 times 3 is 3. So at 1, I'm at 3. So you can see this thing is getting higher a lot faster, and there's 2 reasons why. Because it's going, we horizontal stretch 1/2, so we shrunk the horizontal, and we're stretching it higher. So it's getting them, both are getting tighter, if that makes sense. Okay, we'll do one more here. Let's just do 2. 2 times 2 is 4, minus 1 is 3, so 3 times root 3. So root 3 is going to be like 1.7, so we'll say about 5. And so it's going like this. Okay, much higher. Okay, so the domain for this one is what? Greater than or equal to 1/2. Range. Yep, good. Okay. All right. So now they're giving us an image here, and they're saying state the domain and range here. So this is all about the reflection, which we talked about. So we should be able to get this. So when A and B are positive, that means your stretches are both positive. That means everything's going in the positive direction. So this is just simply your domain is greater than 0. Your range would be greater than or equal to 0. That's just your normal, right? A and B are both positive. So how about when A is negative? When A is negative, where does it reflect? Right, over the x-axis, so y changes. Good, so your domain stays the same, but your range flips. Okay, now this time A is positive, B is negative. So that means your domain flips. Because B, this right here is negative, so it's flipping it over the y-axis. So my domain is now less than or equal to 0. My range is normal. Whoops, normal I said. And then when they're both negative, they're both flipped. Whoops. Let's go range. Oh, sorry. I said both flipped. Domain, range less than. There we go. Okay, any questions on that? That's all for this one. All right, I'll save it real quick.